students, welcome back with we are back with another video, and I'm putting up the question on the screen. Do pause the video and give it a try, and then we'll proceed with the solution. This is a very interesting question that came up in the last year's sample paper for JEE Advanced, published by the Student Council of IIT Kanpur. So pause the video, give it a try, and we shall proceed with the solution. So to proceed with the solution, we have been given toluene as the starting substrate, and it is reacted with N-bromosuccinimide or NBS in a CCl4 medium. Therefore, we know this reagent is used for allylic substitution of bromine, and therefore we get what we call a benzyl bromide. Now this benzyl bromide is reacted with magnesium in a ether medium, which forms a Grignard reagent, which attacks on CO2, and followed by acidification it forms carboxylic acid. So we have a compound C. Now this carboxylic acid in third step is reacted with SOCl2, which is another common reagent which is used for chlorination of acids, and therefore it produces the COCl group. In the fourth step, the COCl is further reacted with ethanol in acidic medium, and therefore it leads to the formation of an ester, which is a compound E. So this is a compound E, and we can see that the two hydrogens that I have drawn specifically are considerably acidic, and therefore they shall be used in the next step, where we are using a base OET minus, and it is subjected to another molecule which is given ETOCOOET, and it has two good leaving groups, and therefore it has a susceptible pi star where S and AE can take place. So the OET minus abstracts one H hydrogen from that carbon, and a carbon ion is formed. The carbon ion attacks on the pi star of the given molecule, and it forms this. Now a lot of you might think that the second hydrogen here will ionize as well, and it will attack on another molecule of the given reagent, but the thing is, the hydrogen will ionize for sure, but as the system is too bulky and it has become so dense around that carbon ion formed, it cannot attack further on the given substrate. Hence this formation shall not take place, and this shall be our final compound F. So we have got these compounds. This was E, and we have to now tally our options that has been given. So to tally the options, the first option says that the degree of unsaturation of F is 6, which is absolutely true because we have 4 here and 2 on both CO bonds, and therefore it is a total of 6, which is correct. Second option says the conversion of E to F takes place by SN2 mechanism, which is incorrect because the mechanism involved is SNAC, or substitution nucleophilic on the acylic bond. Therefore option 2 is incorrect. The third option says that the pKa of phenol is greater than the pKa of C. Now to go back, this was C prepared, and it is a carboxylic acid, as you all can see, and therefore the pKa of phenol shall surely be greater than the pKa of C, which is a carboxylic acid. And the last option states that F has one ester bond. Now this is incorrect because F, the obtained compound, actually has 2 esters, and therefore option D shall be incorrect. So the final answer is option A and C. Do comment down whether you got it on your own or whether you learned something new on this interesting question, and I'm looking forward to your comments, and stay tuned for getting more such interesting questions every day. Keep learning.